Okay, thank you, Steve. So I'm going to talk today about sorry, a MongoDB API to AllegroGraph. And then in our next webcast, I'll actually talk about how we also integrate with Apache Solr. I might show a little bit about that today, but today it's mostly focused on MongoGraph. So before let me go to the next slide. Yeah, before I dive in, I assume that most people in the audience already know what a triple store is. And for those who are unfamiliar with AllegroGraph, it's a very scalable triple store that has all the database features that you might expect of any normal enterprise database. So we have our normal lower layer of database technology, on top a whole range of technologies: SPARQL, Prolog, common logic. We do geospatial reasoning, social network analysis, temporal reasoning. We have an RDFS++ or an ALL- reasoner, and then it's fairly unique. We have also a facility for stored procedures, so we can run JavaScript inside the server, and I'm going to demo that today. And we can obviously run Lisp in the server. And then on top of that, we have a REST interface, so that we have a whole bunch of languages that can talk to the database. As a company, we maintain a Java, both a Sesame and a Gen interface, and a Python interface. And then our customers have written language bindings for a whole range of other customers. And in addition to this, this is an enterprise database, so we do a backup and restore and point-in-time recovery. You can have as many replicas as you want for any single database, and if things go wrong, you can do a warm failover. We offer all kinds of security, both running over SSL, but also we can block some people from seeing some triples. And finally, we have a whole management interface, and I guess you'll see some of that today too. So that's all I'm going to say about AllegroGraph right now. And so we have a long list of customers that play with AllegroGraph, and so we also get questions all the time. And there were two questions that really stood out. One is, can you make inserting and querying JSON documents as easy as MongoDB? Because a lot of people that need a flexible database kind of have a choice. They can go with the triple store, or they can, if they don't do too many joins and they need all the, and they actually just work with JSON objects, then well, they have the choice to go with MongoDB. So anyway, we have customers that want to work with triples, but that also want the ease of MongoDB. And then we get a lot of questions about text indexing. Our triple store does have a full text indexer, but the combination of Solr and Lucene is extremely powerful, so we also integrated that in our triple store. But more about that in our next meeting. Anyway, so about Mongo. Now, I'm going to assume that everyone in the audience knows already what MongoDB is. A very powerful, scalable store to store JSON objects. And if you don't know what it is, this is just a very, very cool tutorial for MongoDB. It's called try.mongodb.org. And if you step through this, if you know JavaScript already and you go through this little tutorial, then you know MongoDB. It must be the easiest database in the world, actually. So that about MongoDB. And so why would anyone want a MongoDB API to a triple store? Well, if you have MongoDB as your database, then adding JSON objects is fast and easy. Getting out of them is relatively easy. But if you need to do anything really complicated, like write a deep join, then you have to start writing MapReduce queries, and it's a lot of programming effort. If you want to, say, treat your MongoDB storage also as a knowledge base, and you want to play with Prolog and rules, well, then I mean, you can't do this. If you have a big graph in your MongoDB database, you will have to write your own social network analysis functions, et cetera, yeah. And if you are really into the semantic web, and then you want to play with this huge new cloud of data called the linked open data cloud, but yeah, how can you combine your stuff in Mongo with this huge body of knowledge on the web. So there's many reasons why you want the ease of MongoDB, but you also want all this functionality on this slide. Yeah. So I guess that's why most people ask us this question: can you make it easy to add JSON objects? So that's what we did. Now we already had, so for us actually adding a MongoDB API was very straightforward, because AllegroGraph already has an in-server JavaScript compiler. Yeah, we wrote it about 2 years ago, and people use it to write stored procedures. I mean, in some cases you want to write your own complex algorithms because you can't do it with SPARQL, or you want it to be super fast, and I mean you want to tailor it to your needs. So then you need to write the algorithms yourself, and so that's what our customers do. Some people write their own query languages or their own reasoners, and in many cases, say you start out with writing SPARQL queries, etc., but then at some point you want to fine-tune the typical queries that you do, and you might want to do that with stored procedures. Yeah, and then another interesting feature that we have is that if you write your stored procedures in JavaScript, then it's very, very easy to actually turn them into a REST calls. So I'm going to demo that too later on in this demo. Yeah, so if you want to know more about our AllegroGraph JavaScript API, just go to Google and type in AllegroGraph France JavaScript, and you get straight to this page here. We give you a whole bunch of JavaScript functions to manipulate parts and triples. For people that know the Sesame API, if you look at these, then it looks kind of the Sesame API. So you can turn any string into a literal or a resource with the namespace, and you can do all kinds of data type manipulations on integers, floats, and seconds, and what have you. Then there is a whole series of functions built in our JavaScript. Well, it's a library on top of JavaScript that allows you to play with triples in the triple store. So let me just take you to a few of them. This is just get triples, where you can fill in subject, predicate, object, and graph, or say a null if you don't want to specify there. You can get your results back as an array. You can delete triples. You can do a commit and a rollback. So if you use a stored procedure, then just like in a normal relational database, you can do all kinds of manipulations, and then at some point you can do a rollback or a commit. If you run in JavaScript, then in your JavaScript you actually can call out to SPARQL or to Prolog, so you can run a SPARQL query, get a cursor back or an array of values, and then you can manipulate that result. And well, it's a whole bunch of other things. We'll send around this presentation, and you can look at it yourself later. Then once you have a programming language in your database, you also can work with AllegroGraph as if it were a graph database. So we have people that write all kinds of graph functions in JavaScript in the triple store. Plus, we offer a whole bunch of predefined functions like a breadth first, depth first, bidirectional search, etc., etc. And if you need anything from a social network library, then we'll just also be happy to write it for you. One thing, when you want to work with JavaScript in the triple store, then the JavaScript hash tables in general are fairly slow if you want to work with the internal parts of our triples. So if you do any serious work with stored procedures, then you want to use our UPI hash tables. UPI stands for Unique Part Identifier. It's just a programming tip, but if you want to do any serious work, you want to use these tables. And then finally, every JavaScript function that you write can be turned into a REST call. And this page specifies how you can do this, but let me just give an example, and I'll do this example live too later. Yeah, so you could write a function to find the unique predicates for a particular class. I'll go into this function later, but once you have defined predicates, then you can just also in JavaScript define this function, server define service. It's a get function in this case. The name is find predicates, and there's one required parameter called CLS. Yeah, and once you've done this, then actually in the browser you can just type in the address of the database you want to work with. You say it's a custom procedure. You get the name of the predicate, and then here's the parameter, the class person, and it will give you back all the types, all the predicates defined for this particular class. So let me demo. So what I'm going to do is I will jump into AllegroGraph web view. This is our web interface to the triplestore. And let me just do one query. Obama, love, hate, same committee. So it's opening the triplestore right now. Let me then execute it. Okay, so the database should open it, but now execute it. See where it's still. Anyway, so what we have here is a database with information spidered about politicians. So every day we spider all the information that we can get on the web on the politicians in the US, and then we link the names of the politicians to other information about these people, like on the committees that they are, and all the text also goes in Solr, so I can do queries like find every text, every person where the text has the word Obama and health and care, and in the text there's two people that are not the same that are on the same committee. Yeah, and you get you can do queries like that. So you get a feel for the data we have in there. But let's go to the JavaScript. So we have one menu item script here, and I could just say, for example, store.size, and I run it, and I get that there's 600,000 triples in this database. I can say store get triples, and if I don't specify anything, I get the first, 100,000 triples back from the triple store. So this is all simple. I could take this thing here, and I say, Nokia null. Type here, null. I can run this, and I get all the triples about, say, Nokia at this point. Yeah. So some little JavaScript. Something more complicated would be, well, let me take a step back. Say you want to get all the unique predicates for a particular class. Now, obviously, you could write that in SPARQL. Yeah. So I have this query already. Yeah. So you just say in SPARQL select distinct P, where the S has the type person, and then give me all predicate objects, and ultimately you get the unique predicates. Yeah, and I execute it, and there it is. But say you wanted to do the same thing in JavaScript and maybe only look at the first 10 instances of a particular class, then you would have a JavaScript procedure like this. I load it. So here you say find predicates. You first make a map, the UPI hash table that I talked about, and then you say give me for all the triples of RDF type, and then CLS. And then for each triple that I find of this particular class, give me all the for each subject of those triples. Give me all the triples again, and then add to the map the mapping from triple predicate to true. Yeah, and then finally return the keys of this map, and then in the same thing we just try it out for, say, person, and I do run, and here I get the results. Now here you see what I talked about earlier in the slides. I can define the server, yeah, and for find predicates on a get procedure with a CLS, so I can run this. And now if I typed here short custom find, oh, here it is already, find predicates, and here I would get a JSON object back with all the predicates for this particular site, for this particular class. Okay, so this about programming in JavaScript in AllegroGraph. Now let me go back to the presentation. And I guess I was about here. So now about MongoGraph. Yeah, here we are. Sorry about that. So what we do, so what is Mongo? Mongo basically does only two things. Well, it does a lot of things, but the most important things that Mongo does are adding a JSON object and retrieving a JSON object. And given that we already have the JavaScript compiler, what we can do is we can take these JSON objects, or we can take JSON objects and turn them into triples, and then what we also do is we store the entire JSON object too. So if I take an arbitrary JSON object like here, A10, B30, C, and then a list of things where there's even another structure, well, actually we turn this into an object where 1 is the ID of the triple, yeah. The first predicate is A and the value 10, and then the fourth argument of the triple, or I guess most people now know about the fourth argument of a triple, the context slot or the graph slot. Yeah, we make that the store name that Mongo uses. Yeah, so all the triples that I add will have store 1 in this case. So, well, here you see A10, B30, C1 and 2, because actually this is still 1-level objects. And then we get a sub-object. So we get a sub-object with name Jans and age 52. And this thing then, and there's a link from 1 to number 2. So here you see the graph that gets created. But for fast retrieval, if you just want to say, give me all the objects where A is 10, yeah, and then instead of reconstituting the entire Mongo object from triples, we also store the JSON object as a blob itself. So we also store the whole document. Yeah. So for retrieval, you very quickly get the stuff back. And so let me demonstrate some Mongo. Let's see. Let's go back here. And the first thing I will do is I will open what I call the webcast demo. It will take a few seconds to set up the database. It's there. There were already some triples in there, so I'll delete the statements. And okay, I'll delete all the statements. Yes, I want to delete all the triples in the triple store. Okay, so now they're deleted. Let me do some Mongo. So let me begin with the most simple thing. I can say add basic. And so here I say store.store1.save. This is the way to save objects. Is name is bar, and bus is another structure with another deep structure inside, and here's another structure completely different from the first one. And then finally I do a commit. Yeah, so I can run this. Nothing spectacular happens. But now say I want to find all the objects back where the name is Jans. So I have another script for that because I don't want to type that all in. So yeah, this is the simple way to find everything. This is for the MongoDB people. You specify a small JSON pattern, and then it will match against the database. So I run this, and I get the results. Well, random data in the name Jans. I actually could click on this, and I go deeper and deeper. Yeah, so this is something simple. Now let's do something where we show how you can do something that you can't that easily do in MongoDB. Let's take let's add a graph to the database. Yeah, so I say find, add a call ring. So what I do is because we use AllegroGraph a lot in telecom, so we're kind of familiar with all the graph search that you can do in the telecom database. But here, just to make things simple, I have a very simple way to specify a little graph. I say Alice calls Bob, and Bob calls Bill, and Bill calls Craig, and Craig calls Alice, and then I commit the triples. Yeah, so I run this. So now I have a bunch of well, I have a small social network in the database, small as possible, I guess, almost. And now let's define a rule to make it easy to work with this graph. So I make a rule that says A calls B if in the triple store there's an object with the name A and the same object has also a predicate calls with the name B. Yeah, so now I can run this one. So now I have a result. Sorry, now I have a rule called calls. Now let's use it. Yeah, I could say Alice calls who? And this is the most simple way to use it. I say find every B where calls Alice B. Yeah, and I run this and we see that Alice calls Bob. Yeah, and now something more complicated. We say find a call ring from Alice. So now this is something you wouldn't do easily. Yeah, this is a join where you say select A, B, C, where Alice calls A, and A calls B, and B calls C, and C calls Alice. Yeah, and I can run this one, and we see Bob, the Alice called Bob, Bob called Bill, Bill called Greg, and Greg called Alice. And so here you see this result. So, and then maybe look a little bit of the triples that we have. So far, so I can say again, S is part from long, so I make a triple part from the integer 3. I take one for name, and then I say store get triples SP null null. So give me all the triples where the ID of the JSON object is 3 and the predicate is name. And I can run, and I get 0 results. So let me take out this. Only let's look at the name, and we do run. We see that, for example, 37 has name, so let me take 37 here. And let me try again with S. Now when I run, I get name Alice out of the triple store. Yeah, so I'm just doing this a little bit interactively just to see how you can play with JavaScript and see the results all at the same time. So the fun part is you are with JavaScript in the database, and you can do whatever you want to do all at the same time. Okay, let's get back to the presentation. So again, I mean, I showed the slide before. So what do you get with this approach? Well, to some extent, you get everything you got from MongoDB. Yeah, you can add objects. Oops, you can add objects and you can retrieve objects. But in addition to that, you can do SPARQL. You get joins all of, well, wherever you want them. You can work with prolog and rules, as I just showed them. You can do social network analysis. And if you work with these JSON objects, you can also now link them to the linked open data cloud. I didn't show that, but it's fairly trivial to see how that will work. So where are we headed with this? Well, we really want your comments and feedback. We're not totally done. We're kind of still seeing how deep we want to go with the whole MongoDB API. Some alternative ideas would be to take AllegroGraph and use it to index MongoDB. So use the two databases next to each other. What I showed you today is we just store all the documents in AllegroGraph itself. And we're kind of thinking about packaging the whole combination of Mongo, Sol, and AllegroGraph, but I'll talk about it in my next webcast. And finally, we're really interested in people that have use cases that need the features of MongoDB, but also want to do graph search. And with that, I want to end my little talk this morning, and I'd like to see whether you have any questions. Yes, the slides from this webinar will be made available almost directly after this webcast, and the whole video of this thing will also be released probably today or otherwise tomorrow. And you'll get an email about that. Or maybe the day thereafter. Sorry. Sorry, that's not a... So another question. Why you not talk about the Lisp interface? Well, AllegroGraph is built in Lisp, but the JavaScript compiler compiles into Lisp, that compiles into machine code. So I've done enough presentations about Lisp, so next time I probably will talk about Lisp again. Then there's a question, will MongoDB be integrated in AllegroGraph? Well, I mean, that's what I talked about in my last slide. That is actually, I mean, you can use AllegroGraph to index a MongoDB database, and so that you could do your joins, or you could store the stuff in it. So I mean, I actually don't know what it means to integrate MongoDB with AllegroGraph. Right now, it's just the MongoDB API. It's not yet in the, oh sorry, there's another question. Is it included with the hosted France product? No, although it would be a fairly small change because it is just some code to take JSON objects and turn them into triples. So it wouldn't be a big change. And of course, you know, we already have the JavaScript in there. Someone says, how does using AllegroGraph only compare to using the combination of MongoDB, Solr, and AllegroGraph? How much extra value do you get with the combination? Well, I mean, so what I try to show you in this other slide is you get a lot of extra value if you use a triple store. But the thing that is actually a lot easier for people that work with JSON is to add JSON to the database. Yeah. So the only thing we did is to add a usability layer to AllegroGraph to make it easier to add JSON objects. Yeah. And MongoDB and JSON and JavaScript are both extremely popular. So we really want to be accommodating to people that work with JavaScript. And Solr is another thing. I mean, we have very fast free text indexing in our triple store, but Lucene, we've done it for the English language and for Chinese and Japanese, but Lucene is, well, it's done for so many languages, and it's such a huge community of people working with Lucene and Solr that we didn't want to rebuild all that functionality ourselves. So we can give you more text indexing features if you use Solr. But in itself, the AllegroGraph free text indexing is, in most cases, just what you want. Then I get some questions about Solr from Alexander. Okay, we'll talk about that in our next webcast. There's a question about, oh, which one is this? Isn't there an index manager in MongoDB already? Yeah, in MongoDB you can add additional indices, but those indices still won't give you joins. Yeah, that's basically what you get from using AllegroGraph. You turn the entire MongoDB JSON objects into something that you can do well, normal queries over that go much deeper. Now, of course, if you use MongoDB to store flat data, then you don't need that. But if there's any kind of graph in there, then you need a join feature. But the indices of MongoDB are not going to help you. Okay, there is a final question. There is still a difference between RDF and JSON documents. The latter doesn't use global URIs. How does AG deal with that issue? That's a very good question. So in the current version of what we did with MongoDB, we actually made a unique ID a literal, and the ID was actually a long. So to some extent, the triples that we generate from JSON are non-RDF. It's just, I mean, AllegroGraph is a graph database, and it really doesn't care about RDF. It just stores graphs, and RDF is a convention on top of a graph database. However, it's a trivial change to make the ID a URI, and then it would be 100% compliant. Yeah, we could stick a namespace in front of the ID of the JSON object and to the predicate, and it would be 100% RDF. Okay. Well, those were a lot of questions. There's even more questions coming in. We'll answer these questions by email. And we thank you very much for your attention. for being here. And I hope to see you next time when we talk about Solar.